Note here, hyperbola is symmetric with respect to both axes and the foci always lie on transverse axis. A hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is a constant. The length of transverse axis is 2a and conjugate axis is 2b. Hello everyone, a warm welcome to one and all. This is Yashati ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to study the last part of a conic section, that is the hyperbola. So what do you mean by a hyperbola? A hyperbola is the set of all points in a plane, the difference of whose distances from two fixed points in the plane is a constant. So I'll take an example of an hyperbola. The hyperbola curve may look like this. This is the hyperbola. So and it is exactly symmetric. You can see whatever you have looking in the negative x-axis, the same shape, exactly mirror image you can see in the positive x-axis. So they are exactly opposite face to each other, that is they are symmetric. So if you consider this as focus F1 and somewhere here as the focus F2. So consider any point P1 on the hyperbola. So the distance from P1 F1 to P2 F2. So that is whatever you take. So which is the maximum distance here? It is P1 F2. So what they have asked, the difference of whose distances from two foci, that is fixed points or nothing but focus, that is P1 F2 minus P1 F1 will be same as take another point P2. So let me take this as P2. So this is P2 F1 P2 F2. So that is P2 F2 minus P2 F1. So take another point P3 here. So just check the distance. It is P3 F2 and from here it is P3 F1. So this is same as the distance P3 F1 minus P3 F2. So the difference of the distances from the two focus to a particular point is same as the difference of the two focuses from the point which is different from the other. So this is same as how many points you take on the ellipse, the distance between the two foci and their difference will be constant for each point. So therefore they have said you the difference of whose distances from two fixed points in the plane is a constant. That two fixed point in the plane is nothing but the focus of the hyperbola. So as in case of ellipse, you will get two orientations of hyperbola. Let's look at it, the standard equations of hyperbolas. So here we have two types of hyperbolas. So here you can see the hyperbola along x-axis and here the hyperbola along y-axis. So here this is called as transverse axis and this is called as conjugate axis. So the line where the foci and the vertices of the hyperbola lie. So the curve touches the x-axis at the point. Those 2 points are called as vertices and they are at a distance a from the curve. So this distance is b. And similarly here, somewhere here, it's a minus b. So you can say here the curve where it touches the x-axis at two distinct points are called as the vertices of hyperbola. So the line where the focus, the vertices of the hyperbola lies is called as transverse axis and the other one is called as conjugate axis. Here you can say y-axis is the transverse axis and x-axis as the conjugate axis. Because here the foci and the vertices lie on the y-axis. So therefore it is called as transverse axis and the opposite axis is called as the conjugate axis. And clearly from these two diagrams you can observe this hyperbola is symmetric here. It's clearly a symmetric one, exactly mirror image to each other. Also the foci, vertices always lie on transverse axes. What are the standard equation of these type of hyperbolas? So for the first case where the transverse axis is x-axis, the equation will be x square by a square minus y square by b square is equal to 1. This is the standard equation of the hyperbola where transverse axis is x-axis. Now here, what is the standard equation? Its standard equation is y square by a square minus x square by b square is equal to 1. So here, the x square and y square term interchange for the second type. So this is y square by a square minus x square by b square is equal to 1. So where the transverse axis is y axis. So clearly you can identify whether the hyperbola given is type 1 or the hyperbola given is type 2. So if the coefficients are in the form of x square by a square minus y square by b square, it is the type 1 hyperbola. If it is y square by a square minus x square by b square, then it is type 2 hyperbola. Just by recognizing the values, we can find out the properties and characteristics of a given hyperbola. Next, note here, hyperbola is symmetric with respect to both axes and the foci always lie on transverse axis. Again, we have here the length of transverse axis is 2a and conjugate axis is 2b. Whereas in the case of ellipse, we take it as major axis and minor axis. Here we take it as transverse axis and conjugate axis. Next we have latus rectum. So we know that latus rectum is a straight line which is perpendicular to the given axis passing through the foci. So as in case of parabola and ellipse, we have a latus rectum for hyperbola also. So consider if this is your transverse axis and here is an hyperbola. So if you consider this as focus F1 and this is another focus F2. A straight line which is perpendicular to the transverse axis. So you can consider this one a straight line which is perpendicular to the transverse axis and which is passing through any one of the foci. This line is called as latus rectum of a hyperbola. So the equation of a latus rectum is again same as an ellipse. It is 2b square divided by a. So thus the latus rectum of an hyperbola is a line segment perpendicular to transverse axis and it is passing through the foci and end points lie on the hyperbola. So it should have an end point at the curve. So these are the end points of the latus rectum and the length of the latus rectum is calculated using the values 2b square divided by a. So thus the length of the latus rectum of an hyperbola is given by the value 2b square divided by a. Apart from this, we have the eccentricity of a hyperbola. As in the case of ellipse, you have the value of eccentricity is equal to c by a and this is same for both type of hyperbola, and the relation between the transverse axis, conjugate axis and the distance of the foci, that is semi-transverse, semi-conjugate axis and distance of a focus is given by c square is equal to a square plus b square. So this is the relationship between the semi-transverse, semi-conjugate and the distance of a foci from the center, that it is equal to c square is equal to a square plus b square, and eccentricity of both hyperbolas are given by c by a. Now let's study the characteristics of given hyperbola. Find the coordinates of the foci and the vertices, the length of latus rectum, eccentricity of a hyperbola. So given the equation in the form of x square by 9 minus y square by 16 is equal to 1. So clearly this is of type 1. So that is, you can compare the equation with x square by a square minus y square by b square is equal to 1. So from this we are getting a square is equal to 9. This implies a is equal to 3. B square is equal to 16. This implies b is equal to 4. So what is c square? It is a square plus b square. That is 9 plus 16 is equal to 25. So if c square is equal to 25, then the value of c is 5. Now let us write the foci. So this type of equation represent the focus and the vertices lie on the x-axis. So on the x-axis, the foci can be written in the form of plus or c comma 0. So therefore it can be written as plus or minus 5 comma 0. Now what about the vertices? Vertices can be written as plus or minus a comma 0. So therefore it becomes plus or minus 3 comma 0. Now next they have asked you the length of latus rectum. So latus rectum is nothing but 2b square divided by a. So what is the value of b square you have? It is 16. So that is 2 into 16 divided by value of a is 3. So clearly it is 32 divided by 3. Next they have asked you to find out the eccentricity of an hyperbola. Eccentricity is nothing but c by a. So what is the value of c we got? It is 5. A is 3. So therefore the value is equal to 5 by 3. Suppose they ask you length of transverse axis. It is 2 into a, which is 2 into 3, 6. Conjugate axis is 2 into b, which is 2 into 4 is equal to 8. So just by naming the values of a, b, c, we can find all the characteristics of a given hyperbola. Next we have y square minus 16x square is equal to 16. So here the coefficient must be equal to 1. So for that what I'll do here, I'll divide the whole equation by 16. Then the equation becomes y square divided by 16 minus x square divided by 1 is equal to 1. So now this is type 2 equation, that is transverse axis is y-axis, that is y square by a square minus x square by b square is equal to 1. So from this we have a square is equal to 16. This implies a is equal to 4. B square is equal to 1. This implies b is equal to 1. We can write c as a square root of a square plus b square. So a square is 16 plus 1. You will get the value as root 17. Now clearly if this is the form of a standard hyperbola, then the focus and vertices lie on y-axis. So therefore, the foci become here 0, plus or minus c. So it becomes 0, plus or minus root 17. Next vertices. Vertices is 0, plus or minus a. So therefore, the value is 0, plus or minus 4. Next, we will write the latus rectum. So, latus rectum is 2b square divided by a. So, the value is b square is also 1. So, it is 2 divided by value of a is 4. So, when you cancel it, you will get the length of latus rectum as half. Next, we have to calculate the eccentricity, which is nothing but c by a. The value of c is root 17 and the value of a is 4. So, the value of eccentricity is root 17 divided by 4. Next one, it is 16x square minus 9y square is equal to 576. We need the coefficient 1 on the right hand side. So, divide throughout equation by 576. So, you will get the value as x square divided by 36 minus y square divided by 64 is equal to 1. Now, this is of type 1 hyperbola, that is transverse axis lie on x-axis. So, therefore, the foci will be in the form of plus or minus c, 0. Vertices will be in the form of plus or minus a, 0. Latus rectum is equal to 2b square by a and eccentricity can be written as c by a. Now let us find the value of a, b, c. So from this we have a square is equal to 36. This implies a is equal to 6. And b square is equal to 64. This implies b is equal to 8. C can be taken as root of a square plus b square. That is, a square is 36 plus 64, which is root 100. So the value will be equal to 10. Now let us write the foci. It is plus or minus 10, 0. Let us write the vertices. It is plus or minus 6, 0. And here 2 into b square, that is 2 into 64 divided by 6. 2 1s are, 2 3s are. So you will get the value as 64 divided by 3. Next we have eccentricity as c by a, which is equal to 10 divided by 6. When you cancels, the value is equal to 5 divided by 3. So this eccentricity of a given hyperbola. So the next type of question is, find the equations of the hyperbola satisfying the given condition. So they will give you any characteristics of the hyperbola. We are supposed to write the standard equation of the hyperbola. Let's see now. We have vertices plus or minus 2, 0, foci plus or minus 3, 0. So by observing, we have x coordinates and y coordinate is 0. So the transverse axis is x-axis here. So the transverse axis is x-axis. So now by writing the vertices, we can find the value of a is equal to 2. And by looking at the foci, we can write the value of c is equal to 3. So if we want b square, then it is c square minus a square. So c square minus a square means it is 3 square 9 minus a square 4, so which is 5. So therefore, if transverse axis lie on x-axis, the standard equation of the parabola is x square by a square minus y square by b square is equal to 1. So this implies x square by a square is 4 minus y square by b square is 5 we got is equal to 1. So this is the required equation of the hyperbola. Next one, foci is 0, plus or minus 13. Length of conjugate axis is 24. So foci means this is of the form 0, plus or minus c. Here, observing the focus, we can say that is transverse axis is y-axis. So clearly from this we get c is equal to 13. Now we have length of conjugate axis, which is nothing but 2b. So if 2b is equal to 24, this implies b is equal to 12. So therefore I can write here b is equal to 12. Next I need to calculate a. So we have a relation that c square is equal to a square plus b square. So if I need a square, then it is c square minus b square. That is 13 square minus 12 square, which is equal to 25. So therefore, I got a square as 25. So now what is the standard equation I get? Y square by a square minus x square by b square is equal to 1. So therefore, I can write y square by 25 minus x square divided by 12 square is 144 is equal to 1. So this is the required equation of the hyperbola. Now the next one is the foci is plus or minus 3 root 5, 0. The length of latus rectum is 8. So therefore here from the focus, since it lies on x coordinate, what we can conclude here it is c is equal to 3 root 5. Now here length of latus rectum. So length of latus rectum can be written as 2b square divided by a. The value is given as 8. So now if it is 8, what I can conclude here? 2b square is equal to 8a. Or when you cancel it, it is 4. So therefore I get b square is equal to 4a. Now we have a relation that is c square is equal to a square plus b square. So when you square this, that is 3 root 5 whole square, it is 3 square into root 5 square, which is 9 into 5, 45. So 45 is equal to a square plus 4a I'll get. So I'll get this as a square plus 4a minus 45 is equal to 0. So solving this, I'll get a square plus 9a minus 5a minus 45 is equal to 0, or a plus 9, a minus 5 is equal to 0. So a cannot be equal to minus 9 because a cannot be negative. So therefore the only possibility is a is equal to 5. So guys, if a is equal to 5, then according to this equation I get b square is equal to 4 into 5. So therefore b square is equal to 20. Now since b square is equal to 20, what I can write the standard equation as x square by, clearly the transverse axis is on x axis. So therefore it is x square by a square, which is nothing but 25, minus y square by b square is 20 is equal to 1. So this is the standard equation of the given hyperbola. Next one, vertices is plus or minus 7, 0, e is equal to 4 by 3. So clearly it is on the x-axis. So therefore the value of a is 7. Now we have e is equal to 4 by 3. So e is actually is equal to c by a. Now let us substitute the value of a here. We have 4 by 3 is equal to c by 7. Let us multiply. We get c is equal to 7 fours are. How much you will get? 28 divided by 3. Now we know the relation, that is c square is equal to a square plus b square. If I need b square, then it is c square minus a square. So what is c square? It is 28 square by 3 square. So the value is equal to 784 divided by minus 9 into 7 square is 49. So on solving this, we get b square value is equal to 343 divided by 9. So here, since the vertices is on the x-axis, the transverse axis is x-axis. So therefore, the general equation will be in the form of x square by a square minus y square by b square is equal to 1. So therefore, equation is x square by a square is 49 minus y square is 343 by 9. When you write it, you can write it as 9y square divided by 343 is equal to 1. So this is the required equation of the hyperbola. So in today's session, we have learned how to write the standard equations of a hyperbola and its characteristics. So this completes your chapter, conic section. We'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.